Hello everyone, welcome to another ALEKS tutorial. So, in the last video, we covered how to find the theoretical yield of a chemical reaction. So, this problem is extremely similar. This is how to calculate the percent yield of a chemical reaction. So, to avoid repetition, I've written out some of the process of this problem already, so let's go through it. In this problem, we have that we start with hexane and oxygen gas, and those two are going to react together and give us carbon dioxide and water. So, we started out with 6.03 grams of hexane and 37 grams of oxygen gas, and in our experiment that we performed, we got 3.27 grams of water produced. So, the only difference between this problem and the last problem was, in the last problem, we were just calculating how much water we were supposed to get out of the reaction. In this problem, we are comparing that value, that what we called theoretical yield, to the experimental yield, which is what this value is. And we use the experimental yield divided by the theoretical yield to get our percent yield. So, much of this that I've written down here is a review of the last problem, so if you are confused by any of this, I highly recommend you look at the last problem because it broke it down a lot slower than I'm about to now. So, I've written this out. We've got our initial masses, 6.03 grams of hexane and 37 grams of oxygen gas, and this produces an experimental yield of H2O of 3.27 grams of water. I wrote out the molar masses of each of the compounds in this equation, and I already wrote a balanced equation. So 2 moles of hexane will react with 19 moles of oxygen gas, and that will produce 12 moles of carbon dioxide and 14 moles of water. So, as we did in the last problem, the thing we have to find now is the limiting reagent, or limiting reactant, whichever one you prefer. So to find this, we need to calculate how many moles of each reactant did we start with. So the initial moles of hexane, which is simplified as C6H14, is as follows. We start with 6.03 grams of hexane, and we can use the molar mass to create a ratio to find the amount of moles that is. So the molar mass of hexane is 86.16736 grams. And just a reminder, again, try to be as specific as possible. Don't round at this stage especially if you are using ALEKS, because you may get the problem wrong. So for every 1 mole of hexane, we have 86.16736 grams of hexane. And if we multiply this out together, of course, grams of hexane cancel, and you end up getting 0. Hold on, my tablet is not writing anymore. There we go. You get 0.0699801 moles of hexane. So that is how many moles of hexane we started with. Let's do the same for O2. So this is initial moles of O2. The problem tells us that we started with 37 grams of O2, and we can use the molar mass to calculate how many moles we started with. So the molar mass of oxygen is 31.9988 grams of oxygen for every 1 mole of oxygen. Grams of oxygen cancel, and we are left with just moles. So plug that into your calculator and you get 1.156294 moles of O2. So these are our initial values for the number of moles of each reactant. We can then use the molar ratio that we found in our balanced equation. We've got, for every 2 moles of hexane, we use up 19. And I apologize, my tablet really doesn't like to write right now. We have 19 moles of O2 for every 2 moles of hexane. So we can write that out as 2 moles of hexane used for every 19 moles of O2. The moles of hexane cancel, and we'll leave you with moles of O2. And this gives us a value of 0.66481110 moles of O2. So this is how many moles of O2 will be used from our initial moles of hexane. And as we can see, that the amount of O2 used up by our initial amount of hexane is much lower than the initial amount of O2. So this means we are going to run out of hexane in this reaction. So what does that mean? That means that hexane is our limiting reagent. So now that we have our limiting reagent, we need to ask ourselves, how much water being the thing that we're calculating the percent yield of, how much water theoretically is produced by our limiting reagent, which is 0.0699801 moles of hexane. So how much water is produced by this much hexane? As we did in the previous problem, all we need to do to find that out is use the molar ratio. So for every 2 moles of hexane, we produce 14 moles of H2O. So to write that out, this is going to be 0.699801 moles of hexane multiplied by the molar ratio, which is for every 2 moles of hexane, we produce 14 moles of water. Moles of hexane will cancel, and you're left with 0.0699801 multiplied by 14 over 2, which is just 7. If you calculate this, you will find that we will produce 0.48980607 moles of H2O. So now all we need to do to find our theoretical yield is convert moles of water to grams of water. We know that the molar mass of water is 18.01 blah blah blah. So let's write that out as 0.489607 moles of H2O multiplied by 18.01508 grams. Oh, I'm sorry. I'm doing this the wrong way round. This is on top, because remember, we want grams of water, so you put the thing that you want on top. Okay? Yeah, we put the thing that we want on top because we want, moles to cancel and leave us with grams, in case that wasn't clear. So, we have grams of water, 18.01508 grams of water for every 1 mole of water. And the moles cancel, and you're left with your moles of water multiplied by how many grams per 1 mole of water. And if you plug that into your calculator, you get 8.82 grams of H2O. And this is the theoretical yield. So, up until this point, all we have done is exactly what we did in the previous problem where we calculated theoretical yield. So, percent yield is exactly the same as our last problem, just with one extra step. And that extra step is this little equation. And this equation is important because not only will you need it for test questions, and for ALEKS, but you will also need it during lab. Your post-lab is probably going to ask you to calculate the percent yield. So the percent yield is equal to the experimental yield divided by the theoretical yield multiplied by 100, which represents a percentage. So what does this give us? Well, if we go back to the beginning of the problem, we can see that in our experiment we produced 3.27 grams of water. And that's our experimental yield. So 3.27 grams of water divided by the theoretical, which we just calculated to be 8.82, multiplied by 100%, will give us our percentage of 37.1%. And this is our percent yield. And this is the answer to this ALEKS problem. So just to be clear, in this problem, we had an experiment, essentially, that we performed in lab using liquid hexane and oxygen gas. We started with 6.03 grams of hexane and 37 grams of oxygen gas. And from that, we produced 3.27 grams of water. Theoretically, it is possible to have produced 8.82 grams of water. You would never get anything more than 8.82 grams of water. This is the maximum possible amount of water that can be produced from 6.03 grams of hexane and 37 grams of oxygen gas. You can never have a percent yield over 100%. If you do, then you've calculated something wrong. And for the record, when you're doing experiments in lab, you're very unlikely to have, an experimental yield that is really close to 100%. That's pretty rare. You would have to be very precise, and even then, it's very difficult to achieve. So 37.1% is actually quite a realistic value for a percent yield. Anyway, I hope this made sense, and I'll see you in the next video.